Hi, my name is Paul Roberts. I'm a technical specialist at Microsoft working with the Defender for IoT platform. This is a short demo about how you can use the platform to start building more meaningful security policies around your OT environment. The first part of any security policy is understanding what's in the environment and what needs protecting. And many of the OT environments have grown over the past 20 or 30 years. They have an OT environment that isn't fully understood. So it's very much a case of you know what you don't know what you don't know. And this platform, by passively monitoring the network, helps build up a picture of what assets are in the environment, who are they communicating with, and how are they communicating. So this demo is based on a demo platform I have at home. I've filled it up with packet captures, so it's data taken from real world environments. And it's just going to give you an idea of how we do what we do and how it's presented on the screen. So this is part of the device asset map. And you can see we've picked up information about devices. Each of these icons here relates to a device. And I can go into the properties of this device and I can see what we've picked up around the type. So it's a PLC, it's from Rockwell Automation. We've got its IP address, its MAC address, what protocols it uses. But we've also got information about devices on the backplane. So in this case, if I click on this device, I can see it's in rack 1 in the default slot. I can see it's a communications adapter. I can see what version it is, what serial number it is, and what model it is. And again, this is all being picked up passively by listening to the network. You can also see there's a blue line coming off of this device. And these two devices here are connected to each other. So by selecting both of them and looking at the connection details, I can see how much traffic is being used and what protocols are being used. So in this case, it's Ethernet IP, which is a Rockwell protocol. And I can tell that there's just over 8 megabytes of data has been transferred. Now we're building up this connection map, which also is going to help us understand what kind of segmentation policies do we need to put in place. And if we already have some in place, how do we validate that those segmentation policies are working? And building up a segmentation policy is a stepping stone to helping build a zero trust policy within the environment. So as more and more of these networks are becoming connected, they're becoming more vulnerable. So we need to take steps to try and fix that. So building up a picture of what's in the environment is very nice, but we also have all of that information as a sheet within an inventory. So for example, I'm now looking at a Siemens PLC, and again, I have the same information. So rack 0, slot 2, I've got what type, the model, the firmware version, etc. And we use this information to start building up an idea of how vulnerable these devices are in the environment, what CVEs can be leveraged against them, and what we can do to remediate against that. So again, we're looking at building up a much better security policy. If we go back to the map, you can see that the map's split into 3 sections. So at the bottom, we have process control. So this is where the PLC sit. And this will be, if you're familiar with the Purdue model, this will be Purdue layer 1. Above that, we have the supervisory area. So this is where the HMIs, the engineering workstations, and anything involved in the management of the OT environment is going to sit. And that will really take us from layer 2 up to layer 3.5. And above that, we have the enterprise environment. Now, we don't actively do anything for the enterprise environment, but we need to understand that it's there because there's connectivity between the enterprise environment and the OT environment. So while we're continuously listening to the network and we're building up an idea of what devices are in the environment, we're also listening to other traffic on the network. And we're using our built-in threat intelligence to scan that traffic and understand if there's anything in the environment that needs attention. And the platform will create a number of different alerts, which effectively act as a call to action. An example would be, we've seen an invalid SMB message that looks like double pulsar backdoor implant. So we're picking up a port scan. Now, a port scan is traditionally associated with an attack or compromise. But in some cases within an OT environment, certain platforms will perform a port scan. So to that end, I can go into the port scan. It will tell me exactly what's happened, what ports have been scanned, what devices are involved. But I've also got the option to learn this behavior. So if I rationalize that that device is actually meant to be scanning this device, then I can click learn. It will add it to a list of acceptable behavior, and I won't be alerted on that again. Likewise, because we have a deep understanding of the OT protocols using a patented machine-to-machine analytics engine, we're able to pick out specific elements within that protocol. So in this case, I've seen an S7 stop PLC command sent from one device to another. So this is telling me that something has happened and I need to pay attention to it. And I've got various options up here around packet captures that I can download, so my security analyst team can engage with this. And also I can look into my event timeline to better understand what happened leading up to that alert. So my alert is now at the top of the timeline, and I can scroll back to see what happened leading up to that. Were there any other malicious activity? But this gives you an idea of the functionality of the platform and how we can use it to threat hunt through the environment.